All right, well, this is it. Here we are in section 12-4. Find sums of infinite geometric series. Infinite meaning goes on forever. Sum meaning we're going to add it all up. So how do you add something that goes on forever? That's what we're going to learn about today. So when we talk about this stuff, and well, there's the music for about time, eh? Vivaldi Gloria we're listening to in the background here today. When we talk about a partial sum, we're talking about the sum, S of n, of the first however many terms. So partial sum is not of an infinite geometric series. We're just talking about, the sum of the first 10 terms of the sequence. The sum of an infinite geometric series with first term a sub 1 and common ratio r is given by this right here. Now, it's the only way we can find the sum, and this is the trick, if r is between -1 and 1. If it's between -1 and 1. If it's greater than 1 or less than -1, then it has no sum. That would be important to note. Take a look at example 1. In example 1, let's see how our r right here is 0.6. And so if our r is 0.6, then it is between 1 and -1. Remember, it has to be on my number line between 1 and -1. And not equal to 1 or -1 also. So 0.6 is between, that's good. So and a, my a sub 1 is going to be 6, and my r is going to be 0.6. So I have 6 divided by 1 minus 0.6. 6 divided by 0.4 is going to equal 15. That means if I add up all those terms all the way to infinity, the result will be 15. And that's kind of a heavy concept when you think about it. 6 plus 3.6 plus, and you're always multiplying by 0.6, and if I add them all up, I get 15. All right, for b there, the first term was 1. The r number was -2/3, and if the r number was -2/3, then it is between 1 and -1, so I can do it. 1 divided by 1 minus -2/3, so that's 1 plus 2/3. And I end up with 3/5. That means if I add up all those numbers, the sum is 3/5. Now understand, some of them are positive, some of them are negative, so that's how you get down to 3/5. And on part C here, you see that the first term is 1, and the second term is -2. So the r had to be -2 because that's what you multiplied to get there. All right, because -2, the absolute value of that is greater than or equal to 1, the sum DNE does not exist. All right, you guys take a look at this checkpoint right here, and take just a minute, pause, and see if you can come up with these ones. All right. Hopefully, you said, oh, this one does not exist because that's 9/7 right there. And this one is going to exist where a sub 1 is going to be 9 over 1 minus 5/6. Well, 9 over 1/6, or 9 divided by 1/6 is the same as 9 times 6, because you flip the second one. Hopefully you got 54 there. And for the next one, 6 over 1 minus, and when you're looking at 10/3, really remember what you have to do to figure this out. You have to do 10/3 divided by 6. Well, 10/3 divided by 6 over 1, or 1/6, ends up being, when we flip this over and then we'll multiply them, we get 10/18 or 5/9 right here. Okay, which means 6 divided by 4/9, because 1 minus 5/9 is 4/9, or 6 times 9/4. And hopefully when you did 6 times 9, you got 54 divided by 4 was 13.5. Okay? Take a look. I got a little joke for us here. I like this one. This next question is going to be about swinging. And so we got this little guy pushing the big guy. Come on, I did it for you. I think that's funny. I don't care if you think it's funny or not. That's funny. All right, so if you're swinging, a person gives one push on a swing, and after the first swing, the person travels 4 feet. So a sub 1, that term, is 4. On each additional swing, you're going to go 75% as much. So 0.4 times, or 4 times 0.75, and 4 times 0.75 squared, 0.75 to the third, and so on. And each time you just multiply by 75%. Obviously, eventually the swing will stop, right, or appear to stop. So we have 4 divided by 1 minus 0.75, or 4 divided by 0.25, which is 16. The swing travels a total distance of 16 feet. All right? So that's a real-world example. All right, you guys take a look at checkpoint 2, and it refers to example 2. So go ahead and do that for a minute. Okay. In example 2, suppose the person travels 3 feet on the first swing. What's the total distance? Hopefully you did 3 divided by 1 minus 0.75, or 3 divided by 0.25, which equaled 12 total feet. All right, last example with some checkpoints to follow. I think these ones are kind of a little bit goofy to do, but we'll go ahead and show you how to turn this into a fraction, essentially. 0.47, repeating. How do we call that a fraction? Remember, we called that rational when we talked about rational numbers because it repeated. Well, remember, rational number means it's a fraction, so I have to be able to show that it is a fraction, and in fact it is. If I take 47 and I multiply it by 0.01, that's 0.47. 0.47. And I add it to 47 times 0.01 squared. If I add it to 0.0047, and then 0.01 again, 0.000047, and you gotta get it. This is how it's a sequence. It's a series. That's how we add it all up. So the first term is 47, and the r is 0.01, 1 minus 0.01. So this fraction becomes 47. I'm sorry. The first term was 0.47, okay, because we multiplied it and we got 0.47. So it becomes 0.47 divided by 0.99. So you see that 0.47 over 0.99, if I multiply the top and the bottom by 100, or I just kind of move the decimal 2 places, I get 47/99. And if you would put in your calculator 47/99, you're going to get 0.47 repeating. Okay, you do the checkpoint 5 and 6. All right, welcome back. Hopefully, on this one, you said, okay, the first term is 0.8, and that constant multiplier had to be 0.1 because it didn't go 2 spaces. It only moved 1 space, 18, 18, 18. 1 minus 0.1, so you end up with 0.8 over 0.9, or 8/9. Okay? And the other one, the next one, 0.63, 0.63, 0.63, that one went 2 spaces again. So we're going to do 0.63 divided by 1 minus 0.01, 0.63 over 0.99, 63/99, which is going to reduce to 7/11. All right, that's 12-4. That's a wrap. That's all of Chapter 12, all of Chapter 11, all done, all done. 1 chapter to go. Trigonometry is up next.